Okay, shall we? So welcome to Kubernetes Meetup 11, which is the new faces and old friends. And we are already 1,100 members in the Meetup. Last event was 1,000 celebrations, so we are really happy with this growth. So Kubernetes Australia respectfully acknowledge the traditional land of the Polynesian people, and we pay our respects to their elders, past, present, and the mayor, and also for the others communities as well. Our mission, we are very passionate about Kubernetes technologies, and our mission is to accelerate Kubernetes adoptions. And we are learning each other and sharing the best practices. So today's talks will be presented by Alexandra Settle. It is Harvest, a cloud-native hyper-converged infrastructure. And this is really interesting. You can run Kubernetes anywhere. And the second talk will be presented by Will. It's about building and operating cloud-native applications with Radius. We have upcoming events. So this is a really nice event. We are really close actually. When it's not 9 of February, we have in Canada AWS. And 6th of March, in 1-2 weeks period, we have it on AWS here in Australia. So I hope to see you soon. And in 26th of March, we have another meetup in Singapore at Google. So if you are in any other place, you can join. We are running these workshops on Kubernetes fundamentals. I don't know if you already joined us in the previous sessions, but this is something that the Kubernetes Australia has started. And we are already on the 102 network and storage. And if you are interested in joining us, this is an online session. Please scan this QR code and register for the next one. We will decide when and we will announce and send emails. Okay. Good. 10, 9, 8, 7, 6, 5, 4, 3, 2. Don't worry if you cannot get now. I will go to later again, okay? Or ask any of the volunteers here can help you with this. I would like to say thank you for our main sponsors, Cloud Native, CloudCasa, and the Kubernetes Cloud. And also for the event sponsors of today, is Microsoft and SUSE. And for Microsoft, I would like to invite Georgia here. Yep, we have it. Just go to the next one. Okay.
Hello everyone, welcome. Beautiful to see all these people with you for the first time. Wow.
Oh, amazing.
That's a lot. That's a lot. I want to know later why we're here for the first time. Means that looks like Kubernetes is something. See, when they used to organize many years ago, wasn't like that. But yeah, glad to see people coming back after COVID and after all these big numbers coming back. I'm just going to quickly have like 3 slides to talk a little bit about containers on Azure, and specifically on Azure Client Service. And yesterday I was showing this slide at the Azure Meetup about containers. And we only have Kubernetes because we started many years ago with Docker containers. And we need containers because of those reasons. We need agility, portability, density, and roughly scaling as well. And
Sorry.
We just lost the slide.
Yeah.
But a lot of people talk for many years about portability. We only use Kubernetes because we can move from AWS to Azure from Google, or moving between clouds, or I can go to on-premise. I can pretty much deploy an application anywhere. And Docker is like, it runs on my machine, runs everywhere now with Docker. We are instructing the way that you run the application. And that's all the reason that we start using containers. We have those things. Next slide. And then come Kubernetes, come the orchestrators. There's a lot of history there, but cutting short, Kubernetes was the one that won, the war of the orchestrators. And many years ago, we used to talk about Docker Swarm and other things, and now Kubernetes is the main one. And why we need the orchestrator? Docker Desktop, anyone using Docker Desktop here for development locally? Docker Desktop, you run your application, everything locally. That works very well for like a single instance. When you have your application, you have Docker Compose, you can compose your application. You have the front end, the back end, even the database running as containers with Docker Desktop locally. It works very well. But then you have to go to production, and you don't want a single instance now. You want to do something scaling out. You want to get now the front end, you have like 5 instances, 10 instances. You have a load balancer that spreads the load across those instances. That's how you have the famous Pokemon Go. That was the traditional demos at the meetups many years ago. When Pokemon Go came and was able to support many users, millions of users, that was Kubernetes. And having the ability to do scheduling, affinity way applications running on the physical nodes, health monitoring, failover. If the instance crash, you just move to another physical node without even the user or the operation care about that. So done by the orchestrator itself, in this case Kubernetes. And then things like outscaling, networking, how you do that in a private networking. Service discovery is a big one, because we don't want to manage IPs anymore. And when the operation has to do firewall burning, wow, there is still a firewall burning. And firewall burning is something that it's dying. It's not dead yet, for sure. It's still people doing. But service discovery now, Kubernetes know where your microservice or your components of application are running. And let's go quickly just through. That's what we call cloud native on Azure. And I always say that AKS is the main one if you want to do full Kubernetes. If you want to do something more serverless, that's not Kubernetes, but container-based, that's Azure Container Apps. And Azure Function could be complete serverless, and it can run as a container as well. And that integrates with all Azure components like security, the open source, the database. And a lot of people, that was my subject many years ago, Azure API Management. And a lot of very good products that you can integrate with those things. And if you're a developer, you want to look for some of those ones. Can you click on it? Yep. That's it. And people say Kubernetes is complex. It is. There's all these things there. But we don't have to care about all those components anymore. Okay? The only thing you have to care is about this. You are a user, you talk with API. Who knows how to call API here? Call API, get a result back. And that's how you talk with Kubernetes. You say, I send you like a YAML file, who likes YAML? Send a YAML file and tell it, can you deploy my front end? I want to have 5 copies of this running. I don't care where. Run that for me. Put a load balancer. Connect on my network. Can you attach a storage account on that? Can you put Azure files on this? Can you make sure that you do a backup? Can you do all that settings? That's Kubernetes. And it's API call. Then that control plane, this side here, you're going to see that's completely obstructed by Azure. And all the networking communications are obstructed by the product. And that's it. The control plane is a black box for you. You don't have to get it. It's completely fully managed. But many years ago, we used to manage all those control planes. That's what we call managed Kubernetes. Is when the control plane is fully managed by the cloud provider. And that's what AKS is a control plane managed. And all these agent nodes, that's where your application is running, the physical VMs, they are also almost fully managed. We do all the patching, we do all the upgrades for you. The only thing you have to do is keep talking with the API. and make sure that when you create the cluster, you define realm of configurations that you want. Okay, and that's it. That's Kubernetes in a nutshell. And they're going to give all that, features like high availability, self-healing. I would say that security now is very important. And I'll upgrade because nobody want to upgrade the end. Thank you so much. And do you want to give away some books?
No, maybe you want to talk about it.
Okay. Yeah, we have a book from Brendan Burns. Brendan was the guy that created Kubernetes. He was, Google employee at the time. He was from Microsoft. And then this book is very nice. I have a few copies there. We're going to give away at the end. So
Yep.
Don't go anywhere. Thanks so much. Welcome.
Thank you.
Thank you, George. So the Kubernetes events only is possible because of our volunteers. I'm here, there, I'm a volunteer, and this is my first time being the MC here. But they also, all these volunteers help this event happens, okay? And if you want to join us as a volunteer, you can join us as a volunteer or as a speaker or as a sponsor as well. You can apply these care codes. Okay. Good. 5, 4, 3, 2.5, 2. Don't worry. All these links is available in our website, and we will share it there. So you can follow us on the LinkedIn, Twitter, or Telegram. We always share them. We are really the most active Kubernetes user group on the web. I'm not thought about it. So follow us, and you will never be behind of what's the latest in the Kubernetes. Okay, this is for feedback, and I will pass the word to Alexandra for now. That's fine. So please, Alexandra, join.
Alrighty. Wrong way. Sorry, guys. We just got Google Slide. We were with Microsoft. Sorry, guys. And we moved to Google, and none of us know how to use it. So that's really, really good, isn't it? Especially considering Kubernetes was done by Google, right? Oh, okay. Right. Well, today I'm going to introduce hyper-converged. So first of all, my name is Alexandra Settle, thanks too long. And I'm the senior product manager at SUSE. I specifically look after Harvester, which is our hyper-converged infrastructure product, and Longhorn. So today we're going to specifically talk about Harvester. I'm going to try and keep the microphone away from me because I do talk very loudly. So if anyone can't hear me for whatever reason, just give me a wave, or if I talk too fast, which I also do. So, okay. So just for context, you probably have never seen me before and might not again. I'm from Brisbane. I've come down for the day to talk to you a little bit about this. I'm joined with some super colleagues here, so you'll meet Rob afterwards, and Santi over here is the marketing manager. So make sure you say hi. And yes, really pale, so it makes it worse. Should I just, okay.
Yes.
Oh, that's All right, cool. So we'll dive in. This is the main agenda for the day. We're going to dive through what is Harvester, overview, especially for those who haven't heard of it before. Can I get a show of hands? Who has heard of it before? David, put your hand down. Who's heard of Rancher? Okay, we've got at least like 3 more. That's not bad. That's not bad. All right, cool. So we'll dive into a bit of what is Harvester. And go over here in the green, can back me up if I say anything silly. Just to give some context, I was previously in engineering on a totally different role. So this is my first engagement as product manager. So if I do say anything wrong, I'm going to get stared at. Thank you. So I apologize in advance if the architecture overview seems a little. So that's what we're going to dive into, high level overview of the build. What I'd love to see from you guys is if you're like, hang on, got some questions, please put your hand up, ask me now, ask around now. I love having interactive conversation with people as these presentations go along. There's sort of nothing worse than getting to the end and everyone going, oh, I forgot what happened, or I don't really understand it at all. So work with me here. I promise I'm really friendly. Then we'll have a look at sort of my what's going on, roadmap, where are we going, what the product's working with, how are we getting there. And then we're going to have demo time, provided everything goes well. And then, yeah, Q&A. So you then get up the courage to ask questions that you forgot to ask before. We can skip the time. Okay. Anything before I kick off? That's the spirit, yeah. Oh, I gotta put that in there. All right. So what is Harvester? I like to sort of really provide those generic overviews to everybody because I think what we tend to do at a lot of meetups like this is we sort of say, oh, okay, it's hyper-converged infrastructure, and everyone goes, sure, but what really is that, right? So it's built for bare metal servers, thumbs up, but HCI, hyper-converged infrastructure, combines all the traditional elements of stack, right? Storage, compute, I'm echoing, sorry. Storage, compute, networking, and management, and virtualizes everything, right? This isn't new, we've seen it a million times before. So why? Okay, so we'll look from cloud native and virtual workloads in data center at the edge, which sounds like, you know, an AI bot, doesn't it? But it provides a single pane of glass, right? For virtualization. You can log in, you go, hang on a second, where is everything? What are we doing? This is what we're up for. It's 100% open source software. So why are we? This Kubernetes. Kubernetes and Longhorn for all your cloud native workloads. And you know the sales pitch, it leverages your agility. Technologies. Okay. This kind of front's like. All right. So we're going to have to like go on the fly. Harvester empowers you to build environments on modern technology. Okay, so one of the things you have, I think one of the big things people talk about at the moment is the Qualcomm acquisition of VMware, right? So put your hands in the air if you had a conversation about VMware in the last week or two. Ooh. So that one guy in the back I have had a conversation about VMware non-stop for weeks. And why? Because VMware's been around for decades. Everybody knows VMware. They know what they do. Virtualization software, right? People didn't have options for years. They went in, they said, what am I going to do? I need to build out, I need to scale out, I need to do this flexibly. So, okay, VMware's it. This is where I'm going unless I build this myself. What Harvester offers is another option there. It's not a drop-in replacement for VMware, I'm not saying that, but it basically uses containers in VMware. So I'm looking at Garage, just getting a little, he's like, ah. But basically, it's using modern open source technologies, right? We're leveraging a totally different environment, and that's what we're encouraging. So no vendor lock-in, proprietary hardware, or proprietary code. You like a Kubernetes API, it's the standard for the entire stack. Okay, so you guys are all familiar with that. Predictable integration with new technologies that meet CNCF standards, such as CNI and CSI. Okay, why Harvester? So again, I modernized these. These used to be orange. I thought they looked terrible. Turned green. So yeah, complete on-premise infrastructure management, VMs and containers supported equally, and powered by Rancher and vendor neutral CNCF standards. So if I said keep saying Rancher, put your hand up if you don't know what that means or what Rancher is. Okay, so only 4 people don't know what Rancher is. Everyone's like, yeah, Rancher's the best. Okay. We'll touch on Rancher later. All right. Benefits, flexibility of both worlds. Performant bare metal or multi-tenant virtualized clusters. So you could run your VMs and containers on top of their metal for high performance and lower overhead, or you can virtualize. So you can have your metal, you can your VMs and run containers on top. Strengths of multi-tenancy and security isolation. Okay, so this is the bit that I actually want Ralph to speak a little bit more to. So why do we care, right? So I could just run Kubernetes on top of myself and add Kubernetes cluster. You want to talk to it?
Oh, it's fine. I'll cover it in the demo.
Okay, he'll cover this in the demo if you want. So one of the things I think that's worth highlighting here is, so when we were planning this talk, you know, we get a lot of questions about virtualization. What's the best option? All right, people come to SUSE and they say, okay, you guys are big on Linux. Why would I come to you guys first? And as I mentioned, we've got our Cluster product, which isn't virtualization. It's not a replacement for VMware, but we have one-click upgrades. We have a fantastic upgrade story. Our optimizable experience when managed by Rancher. Again, Drive will go through that with the demo, which will really cover a lot of bases there. But our lifecycle management, you can easily create, edit, clone, delete VMs. It's all nice and pretty in your single pane of glass. All right, harvester architecture. I'm going to go over this at really high level. So we kind of already touched on a lot of this. So Linux operating system, ACE1C micro, Kubernetes API, virtualization management with KubeVirt. So it provides virtualization management using KVM on top of Kubernetes. Storage management with Longhorn. This probably is going a bit further. Has anyone heard of Longhorn? Familiar with it? Block storage? Guys at the back, I love you. Observability with Grafana predictors as well. Alright, here we go. So I always love putting up little images like this because I think at the beginning of it, you know, you sort of talk to it beforehand before you actually show the image, but it's always nice to visualize it, I think. Alright, looking ahead. So this is sort of where we focus in. So Harvester has been around since 2021. It's a baby. Okay, so when, as most of you are probably familiar with working with open source projects, the first couple of years can be pretty intense. A lot of, you know, okay, we need to do this, or we have a customer that's requesting this, or a community issue that's forcing this forward, and that's a, you know, it's fast paced, it's hectic. And so as Harvest is now really maturing, we're sort of going from where we're thinking of how to plan those roadmaps, we're really changing where we want to do that. So March this year, our key focus will be the big GPU support. Yeah, you're doing. But these have all been really sort of customer driven. What we want to do is take that community focus that we're getting back now and sort of start to form themed roadmaps. So for 1.4, we're going to be focusing a lot on disaster recovery, backup and restore. Something that I personally think is really obviously really important, but we've had a lot of feedback on this story for us and something we really want to focus on. And then for 1.5 and beyond, it's going to be a lot of network and security as well as storage improvements. So you'll see more of that going forward. A couple of things to point out. We're working on ARM support, technical preview at the moment, which will be interesting. I feel very strongly about ARM myself. I'm a bit of a green computing person, so I believe quite strongly in green architecture. And that's one of the things we want to push through as well. So if anyone wants a conversation about green architecture, that's separate to this conversation. Right, how's everyone feeling? That's at least 2 thumbs up, that's all I need. Amazing. All right, buddy, you're up. Did I talk too fast? Thanks, guys. I appreciate that.
I'll try and beat you.
Oh, yeah? It's a race now. I'm gonna stop sharing.
Yep, we need to figure out what to do as well. What do I need to do? You focus on sharing, and then you start sharing. Okay, I should do it. Yeah,
Hello.
that's it. And just hide this one. Yeah, okay. Hi, so I'll try and keep up with Alex's word speed per minute. I may fail, but I may have to take long pauses while I demo some of this stuff. So this is what Harvester looks like. I'm not gonna cover the installation process. If anyone's interested in the install process, go to GitHub Harvester, and all the release artifacts are available on GitHub. There's an ISO, you can download the ISO. There's also IPXE artifacts. There's documentation on how to set up IPC if you want to IPC provision to play. You can even try it out on, if you have a sufficiently big host, you can even try it on a Linux desktop, just using KVM to boot off the ISO. That's what I do when I want to quickly iterate and test features as I develop, because bare metal reboots just take too long. But this is what Harvester looks like. So this is an environment where I'm running the latest RC. Download an ISO that I have available with me. To provision our router.
Hard to say.
Is it better? Yeah. Oh. It wants me to make it wider, or
Zoom.
okay, zoom more. Okay. So there are bigger, but I'm not going to go deep down into the in your home lab. You do not have tagged VLANs available. Sample in your, you can just create a VLAN called workload. You could call it anything. Give it a VLAN ID 1, and by default there's a management cluster, which is the default cluster network that is created. Again, there's fancy things you can do. If you've got multiple NICs, you can configure multiple cluster networks to route traffic. Storage by default long, it's traffic underlying physical space. If you wanted to isolate your storage traffic onto another set of network interfaces, so it doesn't talk with your simple. There's some background which will check whether the network is routable, etc., and then the routing will be marked as ready. As you can say, now to create the virtual machine. So let's say we call it OpenSUSE. You can create a SSH key pair if you want to. I don't have one. We'll use an image that we downloaded. Oops. So you can add multiple disks if you want to have VM with multiple disks. You can add disks later on, etc. Then the networking. So again, this is where you choose the network that you wish to attach to this VM. Underneath all of this is all Kubernetes, and this becomes most evident as you go into the more advanced options. Like, if you want to run on a specific node, basically this is using labeling to pin the VM to a particular set of nodes, etc. I'm just going to stick with the default. And yeah, so you can also do stuff like add your own cloud in it. So for example, to configure a username password, by default, we will install a guest agent so that we can query the details of the VM, and we click create. And it should take a few seconds. It'll become schedulable and the VM will be running. So while we wait for that, I'll quickly go through a few more things, a few more options. So you can also do PCI device pass-through. So if you have physical devices that you wish to pass through to your virtual machines, you can also, basically go in here, enable PCI device pass-through, which will do some work in the background at the Kubernetes layer to bind, rebind devices at the host, make them available for the virtual workloads, and then the VMs get those devices passed through. We can also do network functions. So for example, if you have NICs which support virtual functions, then Harvester will automatically scan your cluster for those devices and make them available here. And you can click enable, define number of functions you want, click enable, and that will go in the background, create those new PCI devices, and those PCI devices for those virtual functions can now then be passed to your VM. So this is the use case where you need high-speed networking for your VM workloads. And last but not least, we're also working on vGPU devices. So again, if you have, the plan is to only have initial support for NVIDIA-based GPUs, which support SRIOV-based vGPUs. So if you have a cluster where you have NVIDIA GPUs, which support that capability, we will scan the hardware and abstract those GPUs as GPU device CRDs. And then you can come in, enable, disable those SRIOV GPUs. So for example, if you want to pass through the full GPU to a virtual machine workload, you can pass the entire GPU. You don't need to use this. But in case you have use cases where you want to slice the GPU across multiple end users or workloads, then we can convert that as well. So once the vGPUs, once the SRIOV GPU is enabled, those GPUs show up. You can create, enable, choose a profile for what sort of profile you want. And again, this is all dependent on your GPU documentation, which will just explain, for a specific GPU type, what one vGPU will support in terms of the maximum resolution, the CPU memory allocated to that vGPU profile. And now this vGPU can also be passed to multiple, one VM, and the idea is you can carve up a GPU into multiple vGPUs, just like your network physical functions, and then pass those virtual GPUs to multiple VM workloads as well. So yeah, as you can see, meanwhile, this VM is up. I didn't really inject anything via cloud in it, but you can see that the UI is also available here. So you can access the console, you can shell into the instances, SSH. So this is address from my underlying network. So again, it's really easy to get started. Yeah. Yep.
You have a diagram of how this works in the report?
Yeah, so I think the high-level diagram is what Alex showed in terms of how it works under the hood. You can also go to docs.harvester.hci.io. What did I say? Hold on. So here you'll find all the information that you need about the product, including what's happening under the hood as well. Yeah, that's what
It will be next week. Sorry.
Yeah, but there's lots of information on how to install and everything else as well.
So every Linux machine runs in a pod inside a Kubernetes cluster?
Yeah, so every Linux machine is basically the QEMU instance, or the libvirt domain is running inside a launcher pod. So the pod is running, and the pod's only job is to run the libvirt domain. And then all the fancy stuff happens, which is abstracted from you, is taking the storage, allocating the storage, making it available to the Kubernetes node. That is what the CSI is doing. Then mounting it inside the pod as block storage. So then, you can partition it, do whatever you wish with it. Obviously, then there's more stuff. As you go deeper, for example, when you attach the network, that is a secondary network attachment using Multis. If anyone uses Multis, it's basically a bridge interface that's created and assigned to the VM. So it is routable directly from the host network or any other network that you define it to be accessible from. Then you can pass through devices, PCI devices, GPUs, virtual functions, whatever you decide to. And then that's also configured in the domain for you. So when the VM boots up, it can see all those things. So I'm not sure if I can show it. maybe here. So that is the launcher pod for the, well, let me zoom in. So that is the launcher pod that is running that VM that we just launched. So if you want to, yeah. So in here, you can see that the PVC claims were created, which attached the disk to it. You can also see the network attachment, all the information. So it's all running on Kubernetes. All you need to know is where to look for stuff, I guess. And that's pretty well documented in the documentation as well. If you find something that's not clear, please feel free to raise the issue and we can make it more clearer if needed. But yeah, so this is what the launcher pod is running, and that's what you see as the end result. So like Alex covered as well, that once you have your virtualization platform running, which is Harvester, you can also do nice things with the Rancher integration. So for example, you can import a Harvester cluster into Rancher and it will show up under virtualization management. So the idea is Rancher does all the RBAC. So you can federate Rancher with any identity provider of your choice and use that identity provider to do RBAC on your downstream resources, which in this case could be VMs, or if you wish to launch workloads directly on the Harvester cluster, containerized workloads, then those can also be launched from right here. So for example, I can go and, so this is the Harvester cluster. I can go create a sample Nginx one. And that will create the Nginx workload. Yeah, sure.
Great.
So it's basically containers and VMs running side by side. Obviously, since you have basically a private cloud, you can also launch more Kubernetes clusters on it. So this is where Rancher shines. I can come in here, choose the cluster I wish to provision on, which is Harvester, the cloud provider. So this is, I already have the cluster set up. I can create the RKE2 cluster. I can say I want 3 machines. I'm not going to change anything else. Okay. I can just use jam. The network I wish to have the VMs on. And if you want to configure your Kubernetes, that can also be done. Anything specific. If you wish, you can store it all as a YAML file and use something like a GitOps based approach to manage the entire life cycle of your workloads, which includes the VMs as well. So that's something we are working on as well. So, and then click create. And in the background now, Harvester will start Rancher will start creating those virtual machines, bootstrap those virtual machines with a cloud in it, which defines how to install RKE2. Then once RKE2 is bootstrapped, there's some health check running, which tells how the nodes, the VMs, in this case, to dial back to Rancher, and then Rancher configures everything else on top. And that's what it uses subsequently to perform in-place Kubernetes upgrades, lifecycle management of the said cluster. So for example, if you wish to, you could even edit the config, and once you have clusters running for a while, you can even configure the upgrade from right here. So I could go here, click this, and as soon as I save, it will start the Kubernetes upgrade for your workload clusters. And last thing is probably the upgrades itself, because Alex briefly touched that in her presentation, that the value is the packaging and the management. So for example, Harvester has an upgrade responder service similar to Rancher. So when a new version of Harvester is made available, the upgrade responder, unless you're in an air-gapped environment, the upgrade responder will check for this endpoint every 24 hours. And once a new version is available, it becomes available. All you need to do is choose the version, click upgrade, and it'll trigger the upgrade where it'll start updating the nodes one by one. And the upgrade process involves swapping out the operating system, the Kubernetes layer, the Longhorn version, while keeping your workloads alive by migrating them around wherever capacity is on the cluster. So obviously you need to have a minimum 3-node cluster to have all the HA capability because of the HCD persistent storage. But it's as simple as that. Even if you're in an air-gapped environment, all the artifacts are published. You can just download them, host them internally, and point Harvester to poll your internal endpoint. And from there, the cluster can see if an upgrade is available, and that can be used to trigger the upgrades if you wish to. So yeah, I think that's mostly everything I had to cover. Unless I've missed out, yes, please.
So basically, Ranch is like the front end management side, and then Harvester provides you on an on-prem virtualization layer. So I think it was akin to OpenStack.
Yeah.
At it. But from you mentioned that you're Grafana Prometheus. So
Yeah.
does that come in at the Rancher level? Or does that come in at the Harvester level?
So the Grafana Prometheus is at the Harvester level, which is right here. Unfortunately, I couldn't scroll enough. So all those metrics are there. So you can access those metrics directly through Harvester. Long story, but a while back, by default, we would install monitoring and logging. And turns out not everyone wants monitoring and logging to be enabled because there might be resource constraints. So if you need monitoring and logging, so we have something called as add-ons. So the idea is not everyone needs everything to be available. So if you wish to have monitoring and logging enabled, you can turn on those add-ons. They're all packaged within the product. And as soon as you enable it, the dashboards and everything show up. But they're all within Harvester. All Rancher does is allows you to proxy to that dashboard. So you can still view all those metrics from one common place if you wish to do. Any more questions? Okay. Great. Thank you.
Thank you. Yeah, our next talk is presented by Will. Do you have a break or not? No? Okay, no break. No break? Yeah, no break.
Just want to stand up, go to the bathroom, because
Yeah.
I'll take time to get ready. So
Yeah, if you will, you're very welcome. This, yeah, 5 minutes, okay? This.
if you want to run away and not come back, I'm not going to get offended.
Yeah. Thank you.
Awesome. I'll get started while everyone is just kind of settling in, settling down. Awesome. Good evening, everyone. How are we all? Good. Yeah. A couple of throwing signs up in the air. Fantastic. That's awesome. Always like to get some lead software engineer working for Mantel Group, based here in Melbourne, but we have hubs all over Australia and New Zealand as well. We're going to chat about building and operating cloud native applications with Radius. Now, who here has heard of Radius? One person, 2, 3, a couple of Microsoft hands in the room. Cool. Yeah, so Radius is a new kind of open source project that has been released by the Microsoft Incubations team. And a little bit about Microsoft Incubations team, the Dapper project. So if I talk about the Dapper project, people have an understanding what that is. People in the room, a couple of nods, no. Okay, that's cool, no worries. You don't need to know Dapper to understand this. It's just essentially the same team. Fun fact, if you're a .NET developer, you'll know Dapper is something else. It's ORM provider. So the team was like, oh, sweet, we'll just call our project Dapper and confuse the entire ecosystem. So with Radius, there's I think an authentication scheme or fee. So this will be fun trying to manage everything at the same time. It's going to have a lot of fun doing this. So yeah, lead software engineer at Azenix by Mantel Group. I work primarily in the Microsoft domain space. I'm a .NET developer. I spend a lot of time in Azure. So Azure Kubernetes service, Azure Container Apps as well, Azure Functions. That's my kind of jam. Before that, I was a fast track engineer working in Microsoft for the mothership. And I was a Microsoft MVP prior to that. I was based in Auckland, New Zealand. So if my accent is a little bit funny, I do apologize in advance. I have an Australian passport, so I'm trying to pick up the accent the more time we spend here. I've had experience working in banking, agricultural, health industries. I never thought I'd be writing code for a bunch of farmers, but it's an amazing way your tech career will take you. And in a former life, I used to play a little bit of rugby, so I was a little bit bigger than this. Yeah, fun fact. Anyway, not what we're here to talk about. So today, I'll talk a little about what Radius is and what it's trying to solve, what problems it's trying to solve. And then I'll go into the concept. So what does an application mean for Radius? What do recipes mean? This is not going to be a cooking presentations. Recipes do actually mean something in Radius. I'll talk about environments in Radius, how we can manage different environments using Radius. I'll touch a little bit into the architecture as well, and then we'll finish off with a bit of a demo. Now, I will ask the obvious question, who here has worked with Kubernetes? Awesome, love to see lots of hands. It's good to see lots of hands at the Kubernetes meetup. Applications are obviously more than Kubernetes, right? It's not just the underlying platform. It's message brokers, it's proxies, container registries, API gateways. For those of you who are kind of maybe triggered by this image, this is the CNCF landscape. There's a lot of choices out there when it comes to technologies. And there are a lot of common problems when we are trying to build cloud-native applications. And standardizing on Kubernetes has been somewhat successful, but enterprise the drinks afterwards, we'd love to hear the stories, because it does come with a lot of complexity with Kubernetes. We don't just run our applications, we also have to operate them. And that's a full-time job. So for those of you who are platform engineers, DevOps engineers, your kind of day-to-day is just making sure all your applications and platforms stay alive, otherwise your customers get very, very angry with you. We also have the issue of developing in isolation. So I still see a lot out in the wilderness where you'll have software engineers kind of sitting in one little corner, platform engineers sitting in the other, and they don't really talk to each other, which is detrimental to our development efforts because these people need to collaborate with each other. And the tools and the frameworks that we use need to kind of aid that. So we do have that kind of problem where application developers may not have the understanding of the cloud platform that their applications are going to run on. And vice versa, we also have the problem where platform engineers really lack understanding about the application that's being built. So together we kind of need a common understanding of what our applications do, how they're going to run, etc. So this is where Radius comes in. So I'm just going to quote this verbatim because it's a beautiful quote about what Radius is. Open source cloud-native application platform that enables developers and operate on cloud-native apps across public and private clouds. It's designed to help that collaboration between developers and operators. So your software engineers in the room will define your application and dependencies, while the operators and the platform engineers will go away and define your environment. What Radius does is try to it attempts to kind of bring those two people together, deploying the applications and infrastructure that meet the requirements for your application. So from an application perspective, Radius application is a primary resource that brings all your services, dependencies, and relationships together. It's really, the aim is to give you kind of like a single description of your application, allowing you to kind of deploy it and manage it a lot more easily. Is by helps us deploy and understand our applications a little bit better and understand the resources that your applications might use, whether you've got containers that are talking to, say, a Redis cache or a SQL database or a MongoDB. Applications essentially have this graph which kind of illustrates all their relationships together. And they're designed to be cloud and platform agnostic. So really the idea is once you've defined your application, you can deploy it to any cloud that Radius supports. Now, currently, sitting here today on the 27th of February, 2024. This is just currently Azure and AWS. So for those of you deploying to GCP, hold on to your hats. It is coming soon. Hopefully. But the idea is because we have this ability to be more portable with our applications, it's great to, this actually helps us in scenarios where we want to move between clouds. Has anyone here done a migration between AWS to Azure or vice versa? Seeing a couple of nods in the room. Also great if you're kind of lifting from on-prem into the cloud, or if you're anyone here deploying to multiple clouds or kind of a high availability disaster recovery. See a couple of nods. Radius can help support that as well. So yeah, I touched a little bit about recipes. So the kind of secret sauce, it's not a pun, I swear, that just came into my head. Recipes are designed to have that kind of separation of concerns between operations and developers by really automating our infrastructure deployment. So I'll be sitting in my little corner saying, okay, as part of this application, I need a container, I need a cache to speak to, I need a backend SQL database, and then what operations platform engineers will do is they'll actually codify their environments to how these resources should be deployed. So on the screen here, apologies at the back, that is quite a small diagram, I do apologize. Say as a developer, I think, okay, as part of this application I'm building, I'm going to need a Redis cache. My platform engineers might develop a recipe. We're saying, okay, this cache is going to be available on Azure. We're going to integrate that into our virtual network. So we're going to need to provision a private endpoint. We also want to do a bit of diagnostic logging. There has to be a certain SKU or plan to support this cache. So essentially, operations will kind of codify that up and expose that as an abstraction to developers. So as far as they're concerned, all I'm calling is a cache. They don't need to sit in their little corner thinking, oh, okay, we're going to deploy to Azure, so we need to define like a particular SKU. That's kind of taken care for them via this recipe that platform engineers have developed. Oh, sorry, I will mention one point, kind of moving in between my notes here. How many of you are using Terraform? I know Terraform is having a bit of a fun time at the moment. Yeah, majority of the people in the room. How many people are using Bicep? One hand. That's all. One hand. One brave man. It's okay. I use Bicep too. Bicep's great. It's better than Ugh. I can say that now and not get punished for it. Yeah. So essentially for today, it is just Bicep and Terraform that you can develop recipes in. Any Pulumi fans in here? Good. I tease. I joke. With out of the box, which I'll show you in the demo later, recipe. Radius does provide some kind of local recipes. So when you initialize a Radius application, there are some recipes that you can use readily available for you. But the kind of power behind all of this is that you can create your own and provide that to your developers. Environments. Okay, so environments in Radius are essentially kind of like landing zones for your Radius applications that's kind of configured with your organization's best practices, settings, and any recipes that you want to develop in-house. They encapsulate and store configuration for your compute platform, network configuration, diagnostics, and any other operational concerns. And the great thing about environments is you can actually configure them to vary across different types of deployments. So you think about your very basic environments, your dev environment, Sage environment, UAT, production. you can build environments around that, and you can also go for more advanced kind of environments as well. So deploying them to different clouds or even different regions if you're working with multi-region applications. So platform engineers will kind of collaborate with your app developers by managing the set of environments that your developers can use. And when your applications are deployed, what Radius does, it actually binds that app to the configuration of the target environment. So all of those relevant settings for that environment are actually automatically applied to your environment. And this really helps in situations for developer velocity. Graph, you don't say, okay, this is my dev environment application, I need to do this, this, and this, and then for staging, production, I have to change my kind of application definition. The application binds to the environment, so the environment kind of takes care of the differences between different environments. Cool. I will do just a little bit of deep dive into the architecture a little bit. I've got a couple of slides on this purely because the demo actually demonstrates this a little bit better. So the overall architecture of Radius has three parts. We've got our general resource management API, the resource providers for our cloud native applications, and then also the tools for kind of managing and deploying our Radius applications via its API. So the Radius API is kind of our single point of entry for all of our applications. So it handles authentication, authorization, and routing. And this is really referred to as the universal control plane. So it's kind of like a hub and spoke architecture where you will make calls to the Radius API. And then depending on what kind of calls you're making, it will route it to specific cloud environments. So if you're using a cache within your application, you say, okay, this cache is going to be deployed to Azure. Essentially, it will kind of route that to your Azure provider. And then within your Radius environment, you can register currently service principals in Azure. You can register a service principal, which kind of makes those authenticated calls on your behalf. There's a whole bunch of resource providers. This is better demonstrated in the demo, but you'll have your kind of core resources for your applications, so your containers, gateways, routes. There is support for secret stores, so Key Vault and KMS and AWS. There is that support coming. It also does have integration with Dapper. It's essentially the same team, so they are kind of trying to build that support with Dapper as well. So it kind of simplifies both application development and deployment. You've got support for the data stores, messaging, and you also have the functionality there to kind of process bicep deployments as well. And then finally, some tools to work with Radius. So predominantly, I'm going to be showing the RAD CLI of how we can actually initialize and actually create our environments. And there's also support for kind of bicep and Terraform. I put work in progress there because Microsoft being Microsoft, bicep is going to be what they support firsthand. That's not, a slight to any Microsoft people in the room. It's just how it is. And then Terraform is just kind of gaining support in the background because lots of people have been using Terraform. So there are customers and developers out there who need that support. Cool. Enough slides. We're going to go into a demo. So I'm going to put the mic here. If I start to mumble, can people at the back start heckling me? And I'll also make sure that that's kind of zoomed in a little bit. Okay, so in this tutorial, I'm going to build a very simple Radius application. So essentially, I'll have a front-end container that's going to talk to a MongoDB database. Also going to show something how it talks to other containers as well, how we can define connections. And I'll also show how we can actually expose that container via gateways and how we can actually use Radius to kind of provision these resources out. So at the moment, essentially, you kind of need three things to get started building Radius applications. So first things first is the RAD CLI. I don't know why I just typed it. I just typed RAD. There we go. So this is how I'm going to kind of interact and build my Radius application. I'll just clear that up. I also need the radius bicep VS Code extension. So this is the insiders version of Visual Studio Code. And there's a very specific reason why I'm using the insiders one rather than, I'll actually zoom out a little bit on that. So hopefully at the back, it's not too bad. Okay, just shout out if you can't see anything, or if you want me to zoom in, because I'm just going to keep going. So essentially, to kind of build on some functionality while not interfering with the main fork of Azure Bicep, essentially they've just done a temporary fork to kind of work on the radius stuff. And once it's ready for kind of production use, they'll look to merge that in. The reason why I'm using a separate version of Visual Studio Code is you can't have two bicep providers working at the same time. It's all good fun. So I've got the insiders version of Visual Studio Code, so I can work with this while having the main bicep one on the stable version of VS Code. And I'm also going to need a supported Kubernetes cluster. Now, to be really simple, or just to get off, just to start with something really simple, I just have Azure Kubernetes cluster provisioned in my Azure subscription. This can be K3D as well. So if you want to do that locally as well, that does support it as well. Also EKS as well. So those are some supported clusters that you can use for Radius. Cool. So the first thing I'm going to do is actually start by creating a new application. So I'm going to create a new directory, K8 app. I'm going to CD into that. And then I am going to initialize a new Radius environment by running rad init. I'm just going to set up a new application. So by default, rad init, that command, kind of gets you up and running with a local development environment where most of the configuration is handled for you. You do have the ability to fully customize that as well through the rad CLI, but this is just something to get started. So what's going to happen is it's going to install Radius onto my Kubernetes cluster. It's going to create a new environment for me. It's going to provide me with a recipe pack there. So that local dev recipe pack are some of the local recipes that I can use out of the box. Hopefully that's not going to take too long, because whenever you share something, whether it's on Zoom or Camtasia, all your demos last like a little bit longer. So there's nothing worse than being in a crowd watching infrastructure being provisioned. So hopefully the more I talk and the more I try and store this whole process, the quicker it will run, because I'm slowly running out of things to say on the fly.
You're so brave.
Tell me about it. Or stupid. We'll find out. Okay, so it's installed. Hooray, it's done one thing. And fantastic. It's created my new environment and it's scaffolded a new application. So before we actually go and see that, it's actually generated a bicep file for me. But before we see that, what I want to do is go rad app show K8 app and just see the application output in JSON. So here's the JSON output. Isn't that fun? So there are a couple of things to note here. One is the ID. So this is what the resource ID will be in the application. So when our Radius system is trying to identify which application we're working with, that's the ID it's going to use. Some of you keen-eyed people at the back will notice that location is global. That's by default at the moment. Your application is not global. It is relative to the location of where your cluster is deployed. I've deployed mine in Australia East, not Southeast, sorry, locals, if you care about that kind of stuff. So that's where my application is. This environment property here, that specifies the Radius environment which the applications are going to bind to at deployment. So this determines where the containers should run and which namespace we're actually going to deploy to as well. So in this case, it's going to be deployed to that default namespace. And then compute kind of just specifies where the running services are actually going to run. So when I was in Microsoft, and this was called Project Radius, not Radius Project. So when it was super secret, it was Project Radius. And when they decided to reveal it to the world, we were just like, well, what are we going to call this thing? We'll just swap the words around. Again, no shade, just saying it's probably better than I would have done. So yeah, it was all running on Azure Container Apps. So now it's all running on Azure, just on Kubernetes. So you might see that in the future, you'll be able to run Radius environments on Azure Container Apps. You might be able to run it on Fargate. I'm not sure. Watch this space. Cool. So let me just clear that up. And what I'm going to do is that we're going to look inside the application to see what's deployed. We can do that running rad app connections, and nothing's deployed, which is good because we haven't done anything. So what we're going to do is we're going to inspect and our app bicep file that was kind of deployed. So right out of the box, we've got kind of a demo front-end container. So think about your building kind of like a UI that's going to talk to a backend container. It's going to talk to a database. This is essentially what we're going to build out. So what right out of the box, we get a nice little demo container that's going to be exposed on localhost 3000. So to deploy this, all I need to do is go rad deploy. I'll deploy that bicep file. So that's going to go ahead and just kind of build my bicep file, make sure that's all good. And then it's going to deploy that application, K8's app, into my default environment in that workspace. So there we go. There's my container being deployed. It's going to take really, really quick because all it is a container. We're not going to have the demo overlords store me. Please. Awesome, there we go. Right, so now if I run that rad app connections, we should see our container being deployed, and we have some underlying Kubernetes resources that have been deployed as well. So I've got my service accounts, I've got roles that have been created for me. So what's happened is those Radius environments kind of map to the applications. Radius applications really map how applications bind to a particular platform. So earlier in that kind of, I showed you the compute was set to Kubernetes, the namespace was set to default. So this means that our container resources were deployed to that namespace in our Kubernetes cluster. So what I'm going to do is I'll just not do that. Let me run my application. So once that starts running, we should see kind of a log stream being served up. Things being deployed. Should already be there, so it shouldn't take too long. Fantastic. So cool, we're getting a log stream going. So now if I navigate to localhost 3000, I can see my container has been deployed. Woo! Fantastic. And we can view all kinds of stuff. So this is just a base image that the Radius team have provided, just to kind of show you how everything connects up. So here, Radius connections, pay attention to the sections because nothing's been defined yet, but we're going to add stuff to it. We can see some metadata for our container, so network configuration, the process information, any environment variables as well. And I've got this handy kind of to-do list. Nothing's been configured, so all our items are going to be stored in memory. So if I ran that again, we would see that item being disappeared. So that's not good. Essentially, we'll need something to persist to. So next, we are going to add our database. So if I go back into Visual Studio Code, what I'm going to do is I'm going to add a description for my Radius environment. I can put environment. And then what I'm going to do, I'm just looking at the time. I'm going to add a MongoDB database. So I'm just going to call this recipe. So what I'll do is I'll just add, let's start typing. So you've got all these namespaces available to you. So you've kind of got your core resources, applications, containers, environments, gateways, secret stores, volumes, etc. For Dapper, we've got access to secret stores, state stores, pub sub brokers, and just messaging brokers, different type of data stores, so Mongo, Redis, and SQL for the moment. Just one messaging for the moment, so RabbitMQ. So essentially what I've done here is just created a MongoDB database. Now the thing to notice here is I haven't defined or specified how or where to run the underlying infrastructure. All I've really done is just say, hey, I need a MongoDB database as part of my application. And the Radius environment and the recipes will actually take care of how and where that infrastructure is going to be run for me. So, and one little thing we can do, I'll actually copy and paste this, go back into the command line. I will clear you up. If you're using a Radius, using a recipe, and you're consuming that for the first time, you know the namespace, but you don't really know a lot about it, you can actually use the rad CLI to find out a bit more information about that recipe. So for my MongoDB database, I press enter. That should show me a little bit more details about the recipe. So what type it is, what the template is, so you can actually store your recipes in a container registry, Azure Container Registry, stuff like that. And then you can see the parameters that you can provide with default values as well. So those of you familiar with Bicep will see this is somewhat familiar or similar, sorry, to what a module is. In Bicep, Radius is almost pretty much the same thing. Cool. So now I want to be able to add that connection or connect my MongoDB database to my front-end container. And to do that, what I'm going to do, maybe one space down, add some connections. I'm going to add the ID of my MongoDB database resource, like that. And that is going to connect my MongoDB database to my container. So what I'll do again, just clear that up, red run. The reason why I'm clearing the terminal each time, for people at the back, I was running a demo one time and I was doing stuff down there. So people at the back can't see. If you're at the front, it's great. But for people at the back, it's not that accessible. So, you know, learned my lesson there. So that's why I keep clearing it each time. That was the kind of thing I was going to store while this is progressing or trying to deploy, rather than just letting the silence sit. So yeah, now my MongoDB database has been deployed, so that's completed. Essentially, what you may notice is as I'm defining connections between different resources, the deployment process kind of maps out like a dependency graph. So it will deploy all your dependent resources first, and then it will deploy resources at the end. So it's not like your container will just spin up and then start throwing errors saying, hey, where's my MongoDB database? Essentially, Radius kind of maps out. That's part of the application graph that was created. So that's a lot of logs, which is cool, fun. We like that. So now, if I refresh this, I should see, ta-da, my MongoDB database has now been connected to my front-end container. So there I can see my environment variables, so the password in plain text so everyone can see, which is great, where my MongoDB database is hosted, the port it's on, etc. And if I go back into my to-do list, that warning's gone away. So I added test item. So now my data is now being persisted to that MongoDB database application instance, sorry. So if I actually control C out of that, I'll clear that up. So now if I run rad app connections, we should see our MongoDB database has been provisioned as well as the underlying resources in Kubernetes that have been created to support that application, to support that MongoDB database. So for those of you who's like working with microservices day to day, no unlucky souls or reluctant people. So a couple of hands, one person at the back. Probably why you're standing at the back. Sorry, don't mean to pick on you. No, it's okay. Essentially, Radius has that ability to kind of make your code more modular as well. So if I just add in, not you, I'm going to add in a just a backend container. I can essentially, all right, that's going to be exposed on port 80. I can essentially add that as a connection to my container. So if you have services that talk to each other, or specific services that talk to each other, you can just add them as connections within your container. So here, what I'm going to do, just add that to the source, make sure I get this right. So that's going to be exposed on port. So I'll call it the name of my backend container. And that will add the backend container. Now, just because we're a little bit pressed for time, when we're connecting to localhost 3000, we're actually connecting to our container directly. And ideally, we don't really want to do that. So what we want to do is kind of add a gateway. So Radius will actually, not you. Radius has kind of like a gateway recipe for us exposed out of the box. So I'll just copy and paste because I'm running a little bit out of time. Cool, so there we go. So essentially that will kind of create a gateway, and we're basically routing it to our container that's running on port 3000. So the name of my container, demo, I love using my trackpad, and essentially pointing it to localhost 3000. So what I'm going to do now is just clear that up, rad deploy app.bicep. Cool, so that's going to deploy everything. So what we should see once everything has been deployed, we should see a public endpoint made available to us as part of our application. So there, kind of see that dependency going in. I'm pointing on a screen with people on Zoom, which is very unfamiliar with me, I apologize. So our MongoDB database is kind of being created. Gateway was created first, so that's ready. Our backend then gets provisioned as well. So then our front end container, our demo container, can get provisioned now that all its dependencies have been created. Cool. So there's the gateway. So rather than connecting to my application to my container directly, I'm now connecting via the gateway. So it's not secure, which is not great, but it doesn't matter. But there is my gateway. That's kind of I'm exposing my application on. There's my MongoDB database. There's my backend container that's all connected up. So if I go back into my to-do list, demo, successful, question mark. Everything worked, whether it landed with you is up to your judgment and feedback. Anyway, so that's kind of, that's a very basic how to kind of deploy and get started with Radius. I will show you a little bit of code just before I finish off. Hopefully it's sitting in here. So in this kind of example, I've got a front-end kind of container that's talking to a Redis cache. Now, if you can see it at the back, I will zoom in just a little bit to make it a little bit more friendly, and I'll get some more real estate there. All I've essentially done to say that, okay, this cache is going to be deployed to Azure is define this recipe block and just use the name Azure. So I'm going to be using the default recipe that's provided for Azure to deploy my cache. So if I just go into GitHub, one thing that the team is currently working on is a whole bunch of recipes that are being developed by the community to be made available within Radius applications. So Azure is getting a little bit of love at the moment. So there's support for Service Bus, SQL database, state stores, which is like a Dapper state store, which is using just a storage container. But there's some ones out of the box for kind of local development. So we use the MongoDB database. There's Redis cache as well, SQL databases, etc. As you can see, it's very light at the moment, so it's very early stages. One thing that the team is kind of working on is actually adding a contribution guide. So folks like you in the community can say, okay, well, this recipe would be great. How can we actually contribute back to the project if you want to contribute to the Raise project itself? I'm not sure why that's taking so long, so I'll just open that up. Yeah, and they've got a whole wide of like different initiatives on the go. So the Radius engine itself is kind of built on Go. There's also samples there, docs as well. So if you are looking to get involved pretty early within an open source project, I really recommend you do that. I'm kind of working on the recipes, or started to work on the recipes. The team is really responsive. This is kind of like their full-time job. So they are really supportive of the community getting involved. I'll just go back to my slides. As far as kind of where they sit within the CNCF, they have submitted to it kind of as a sandbox project at the moment. So it is something that they want to kind of push through the CNCF and graduate it. I put in the slide before the Linkerd stuff went down. So if you are kind of affected by that, I do apologize. Anyway, yeah, if you want to get involved with Radius, they have a Discord, super friendly, super responsive on Discord. I don't know why K has come up, but it's gone now. Check out them out on GitHub, and their docs are really kind of simple to use. If you see something missing in there, I'm trying to get some clarification around how secret stores are going to be working at the moment. And they're really super responsive to that. Awesome. I'll get back on the mic. Thanks for listening. That was a lot. I talked very quickly. Maybe, I don't know, same pace.
It felt good.
It felt great.
I felt like I had a friend. You know?
Okay, that's good. Good. We don't leave anyone alone up here. It's better to speak to it quickly. Better to speak quickly, especially when you're talking to your bosses. Speak as quickly as you can, so they're like, great, awesome,
And then run.
sounds terrific, and then run.
Oh.
Exactly. Thank you all for listening. If you do want to connect with me, the great thing about having a name like Will Velida is I'm pretty unique on the internet, so I'm kind of easy to find. I'm not sure if that's a good thing or not. But I'm on GitHub, Twitter. I'm not going to call it X. Apologies to Elon fans in the room. That's just who I am. LinkedIn, and also I'm starting to get back into the YouTube stuff. So if you want to, I have got a video on Radius there. It is a bit long, but if you did miss out on anything, I do cover those concepts on my YouTube. So thank you.
Thanks, Will. That is a very good informative session, and also a very good thing. Don't just go away, guys. Just kidding. Okay, the last fun part, we are asking you guys to help us to improve. So we're going to have a few feedback forms, actually quite a few. And the QR code, yeah, I know we got a lot of the QR codes. And we have some awesome giveaways. We need to test you guys. If you guys pass the test, you can join the lucky draw. You can join the quiz time, and then you can win the swag. I know we got lost a few of the swag, but it's all right. As long as you guys agree, help us to promote our events. So it's all good. So we still have quite a few books. Actually, quite a nice book.
What's the goal?
Yeah, everybody. Yeah.
So after the quiz time, we're going to give away all the swags. Okay.
Thank you.
And also, you will notice in the survey, if you want to join me to learn a lot of stuff, you can join me to learn. I included a lot of links inside the survey form. And yeah, we're going to give like 2 minutes for the survey, and then we'll.
Yeah, just wait for a while. Yeah.
So I think one of the best swag. I don't have anything to show you, but it's so good. It's a cold cloud access. Have you guys heard of the cold cloud? Yeah. So cold cloud is the best loading platform for the Kubernetes loading. So we're going to give away 3 6-month cold cloud subscription. All right, shortly, we're going to test what you guys learned. Did you guys actually learn something? So we will have the quiz time based on what the speakers just talked about. So how is
Define.
Internet's just okay. So we're getting things ready. Then you guys can join the fun quiz game. Yeah, in case you miss, we're going to give away 3 cool cloud access. That's probably the most valuable swag. Yeah. So if you purchase from the website, it might cost you like $500. even after this constraint starts. So I'm able to meet the founder last November at the Chicago Cubicle event, and the founder agreed to support us. Every meetup, we're going to give away 6 months access. So that's a very good deal. So, guys, if you guys want to look, that's the best look. So let's start with the testing. All right, are we ready? No, we are not ready. So I can see we should have more than 10 people, right? Refresh the screen. Oh, okay. Oh, participants. Sorry, my mistake. Yeah, this is also a pretty new platform we just started using. Well, that looks good. Yeah, we're gonna show the eye. So let's get started. The first one. I think are we all ready? I saw someone still taking a photo. Yeah. Let's give another few seconds. All right, we've got a 39, 43. Yeah. Cool. The first question should be a very easy one. Let's see. When did the Harvest go GA? Yeah, if you listen to Alex's session, it should be easy one. We've got 10 seconds. Is that 2019, 2020, 2021, or 2022? All right, now let's see the leaderboard. We're gonna Remo is the top. Will also did a very good job. Yeah, not too bad. We got 61%, gets the correct answer. Next one. What literature is used in Harvest? Is a marker KS, K3S, a K0S, or RKE2? All right, let's see this time who is on the top. Oh, come on. I know you guys are hold of the marker KS, so we got a 40% voted marker KS, but the correct answer is RKE2. So this time we're gonna Chris down to the top. The next question, what kind of workload can Harvest run? Is it containerized apps? Is it VMs? Or all of the above? This one should be the easiest question, I think. 5 seconds. Oh, nice. We're gonna 93% get correct. 91. Next question, what is the default CSI for workloads on Harvest? Is it local fast provision? Is it NFS or long haul?
No. Oh, she was here. Oh,
Let's see. Yeah, pretty nice. We've got 84% correct. Awesome. So it looks like the top 3. Yeah, where's Chris? Please move to the number three.
No, no, no.
I don't know if I pronounce it correctly. Henry, Ray.
No, if you want, if you really want, I give you.
Next question.
I'm going to write you here. Okay. I will need some stickers, but I have some stickers on. Yeah.
What is a roadmap for harvest 1.5.0? Is it DR and the restore or H or network and security improvement? Yeah, this is pretty tough.
It's not junior now, but then the GitHub was waiting for that.
Let's see who gets the correct. Yeah, I know it's 37. All right, we got
I got my
all of the harvest done. Now let's move to the next part.
yeah, too many.
These are like uni ones, yeah.
Raymond,
Yeah, this is
go to the top.
this is
Nice.
for long.
What use infra as a container for the environment to create a cloud resources when an application is deployed?
Yeah, totally. I see.
It's a recipe, it's a cookbook, it's the ingredients, or the utensils. Oh, nice. Yeah, we got a 90%. I get it correct. So amazing. Oh, even 86 also pretty good. Congratulations. Rainbows. Oh, amazing. The next question. In Radiant, what provides a landing zone of applications that are configured with the organization, choose best practice, setting, and recipe? Is it environment? Is it templates, namespaces, or clusters? Yeah, the correct answer is the environment. Yeah, not too bad, 55%. Amazing, it looks like a Rainbow, Henry, Will are still the top three. The next question, let's see how hard is this one. Using the red CLI, how can you create a new radius environment? Is it radius red init, red create, red new, or red time? Yeah, I saw in the demo. Yeah, yeah, yeah. It should be very easy, I think. Amazing. 85. Get it correct. So looks like a no change to the top three. Yeah, two more questions. Currently, which platform are you unable to run Radius applications? Yeah, I heard clearly from a Will. He did mention that one of these actually doesn't work. I mean, right now it doesn't work yet. Is it GCP or Azure or AWS or on-prem? Yeah, not too bad. We got 54 answered correct. Congratulations, Henry. Henry moved to the top straight away. Last chance. Even you just want answer this correct question, very quickly, you can, move to the top. Using the red CLI, how can you run Radius applications? Is that red run app.bicep? Is that red deploy app.bicep? Or red start app bicep? Oh my God, it's tough for me to read these. Yeah. Almost time. Let's see. Amazing, Will. Oh. You want to give away? You want to pass? Okay, awesome. Yeah, we are going to give away. So the first few guys, you got the choice. You can either choose any one of the swags here, or you can choose the code cloud access. And after after a few more, you got no choice. Okay. Let's see. So the first one, yeah, as usual, we normally invite you guys to take a photo with us. Okay. If you guys don't mind for the winners. So Will, you definitely don't want it? Yeah, well, okay, yeah. If you want to bring to your kids, everyone eligible to purchase to join. Okay. So if you don't want, yeah, seriously, you want to give number 4? Yeah. Okay. So who is Henry? No, that's what you are going to give him. Yeah.
Yeah, because I made half the question.
Okay. So the
This is fine. This will.
Oh, no, we want to take a photo with you.
Oh, okay.
You're the winner. Where's our cameraman? All right. Thanks. Yeah, the next one is that N taker. Congratulations. Yeah, you know a lot of things that you access also. You can decide, yeah. Yeah, code cloud access. I don't have anything to do. All right. Thank you. Yeah. Oh, okay. I need you to give us the full name and the email address. We will give you the code product. Yeah, the next one, Rodriguez. Sorry, it's hard for me to pronounce the name. No problem. Okay, Roger is better, yeah. Which one you take? The big one, the small one. The big one, yeah. Yeah. Let's take a photo. Hold this, take a photo. Okay. All right. Thanks. Yeah. Who is next? Harry. Yeah, Harry, come here. All right. Which one you decided to choose? Code cloud access. Oh, yeah, that's awesome. Yeah, that's a nice choice. So we got one more code cloud access, but you can choose any other stickers or anything. And what's the name? PMB, right? Okay. What's left? Yeah. Okay. You want to take that one?
Yeah.
Or you want to code cloud access?
The big one.
No, too late. Next time. I still, we still have something here. Don't just go away. We're gonna everybody have something, okay? At least stickers. So who is Manik? You want to Do you want to call it cloud access? Well, that's awesome, yeah. All right. So you let us know your full name, email address, and Zai School. Who is Zai School? I don't know if I pronounce it correctly. If not here, so the number 7 not here. So let's go Remo. You already got one. But how come? We haven't taken a photo yet. Come on, let's take a photo, guys. Yeah, we're gonna something else. Who is Sunny? Who is Sunny? Okay. Yeah, Sunny. Okay. You want to take this one? It's a penny pack. Yeah. More stickers, and you're free to make some stickers. Yeah, if you guys don't mind, yeah, do you mind, come over here, we take a group photo. And then I got one box of the swags, small swags, feel free to take, okay? So may I invite everyone to come here? Let's take a group photo, please. Thank you so much. Thanks for holding this. Hey people, picture. Everybody say Kubernetes. Thank you.